Okay. Good morning, all of you. So today is our talk about functions. Mainly. So there are 4 diagrams you can see. Actually 4 relations. All are relations. Relations means relation is a subset of the Cartesian product, right? Any relation is a subset of the Cartesian product. That is a very important word. Cartesian product means, do you have any concept about Cartesian product? Yes, Cartesian product means if you're talking about 2 sets A and B, then the elements are in order pair actually. Just like coordinates. Just like coordinates. A belongs to the set capital A, B belongs to the capital B. So actually A, B order pair. Elements are in always in order pair. So you see relation, any kind of relation. Relation is a subset of the Cartesian product. So this is also all are relations.
Sir, I think your net is going low.
Net is very low.
It's coming here.
So are you connected to Wi-Fi?
No, I don't know. Yeah, they may be connected to Wi-Fi.
It's the person who's there in the side.
Okay, just wait. দাদা শুনুন নেটওয়ার্ক একটু প্রবলেম আছে আপনি এখানে থাকুন না ওখান থেকে সুবিধা হবে কারণ এই যে ওরা যদি কিছু বলে আমি লেকচারের মাঝখানে থামাতে হচ্ছে আমার আচ্ছা yes actually some poor network wait Ishan it will be solved okay the first diagram. Now the question is not all are functions. What about the first function? First diagram. Is it a function? What is your knowledge? You just guess. I will explain. It is a function. Shapnil? Function. Ishan?
Yes, sir.
First one is a function, right?
Yes, sir.
No, it is not a function. Why? Because D has no image. D is not related to any element in B set.
Okay, sir. I couldn't even see that D out there.
Okay. So every element in A has a unique image. That is the first criteria. Every element in A has a unique image. That's the first criteria. So D is not related. D has no image. So it cannot be a function, but it is a relation. Am I clear? Number 2.
So are all relations functions?
No. Functions, all functions are relations, but not all relations are functions. So these are all relations, but this is not a function. Why? You can note down the reason also. D has no image. Clear? Now, what about number 2? Just
No, sir. It is not a function.
It is not a function. Why?
So because
The first one is related to
Yes,
2 of them.
one to many is not possible in function. I say the word unique. Actually, here, this word is violated. Every element in A should have an image. This word is violated here. Here, unique word is violated. There must be a unique image, but A has 2 images. So one to many is not possible. So I'm using some important words. You can take a note of that also. One to many in function is not possible. Many to one is possible. So this is not a function. Am I clear? Every word is violated. Unique word is violated. So now you can define the function. So I can write the definition of function for each element x in A. For each element x in A, there must be a unique element y in B. So for each element x in A, there exists, this symbol is there exists, an element y in B, unique element, such that we write y is a function of x. We write this is a function or transformation. So what about the third one? It's clearly a function because every element in A has an image and the image is unique. What about the fourth one? What is your confusion? Your confusion is A and D. A has an image 2, D has an yes. Many to 1 is possible.
Yes,
One
sir,
to
it is
many
a
not possible.
function.
Clear? Yeah. Any questions out of this 4? This is the concept of function. Is it clear?
Yes.
If it is a function, it is called the domain of the function. Okay? And if it is a function, this part is called the codomain. And these are the actually range set. The values, the image set. These are called the range set sometimes. So this range set is equal to the codomain. Okay? It can have 4 as a point. It's not necessarily that 4 is an image of some point, but it can still be a function. There won't be any problem of having a function.
But if there was an E,
Yes, that must have an image. Okay, clear? And this point, suppose you have a 1, this is the image. B is called the pre-image of 1. B is called the pre-image of 1. A is called the pre-image of 2. C is called the pre-image of 3. These are the languages. I will use these languages. Okay? Now, I will go to types of functions. Domain range, we will do that part. Maybe you know, suppose if I are talking about a linear functions or polynomial, there are many kind of functions. You know, trigonometric functions. This very special kind of functions is a trigonometric function. So you can talk about sin x, cos x, etc. Right? So if I talk about sin x, cos x, then what is the domain of sin x? Can you tell me the domain of sin x? Domain of sin x. Domain. If you draw the diagram, this is a sine wave.
Sir, it is minus infinity to plus infinity.
Yes, this horizontal expansion is the domain, right? Because I said that if you have A, this side is the A set, A to B. This is your B set, right? So it's a mapping transformation. The points are here. So you can draw the curve like that. So this is your curve sin x. So your domain is the horizontal part is a domain. So your domain is minus infinity to infinity. So what about the range?
Minus 1 to 1.
Look at that. It's confined between this portion. So this is the range, minimum value, maximum value. So sin x and cos x is confined between -1 and 1. So similarly, you can write the domain and range of all other functions. Polynomial functions, you can write down the parabola also. This is a parabola. What is the domain of the parabola? It depends on the functional form of the parabola. But what is the range of this parabola? You see 0 to infinity. Lower part is 0 and upper part is goes to infinity. Right? So you can write. What about the exponential function? Let us draw an exponential function. This is, you know that exponential functions are increasing. So what is the domain of exponential function? Plus infinity, correct. And what is the range? Positive half of the real axis, you see? Positive half of y-axis, so 0 to infinity. Correct? And what about log x? Log x will be like this. Log x is the inverse function of exponential function. I will talk about it. Yes. So it's a positive. Log x cannot be negative, x cannot be 0, undefined. So this kind of thing you can. So graphical knowledge is very, very important. Actually, I took the class on graphical part of class 11, right? So that part is very.
So if you have the recording.
Yes, you can ask ma'am. Ma'am will share with you. They have the recordings with you.
So I can
So
go through it.
yes, I'm just take a note of that. Graphs. You need a knowledge on graphs. Again, I will actually, when we'll do problem analysis, then we will find out more concepts on graphs, problems analysis. I will create. Now I will go to types of functions. Types of functions, first type is one-to-one or injective, sometimes it is called. Okay. So let me draw the third diagram, what I have drawn. Let me start with the diagram. This is an example of one-to-one. This is an example of one-to-one. Why? So there is a criteria. If I write mathematically, so x1 not equal to x2 implies if x1 not equal to if x2. That means you have some two distinct points. X1 not equal to x2 implies two different points, two distinct points. Their images will be distinct also. So that's the criteria of one-to-one. Or conversely, number 2. If x1 equal to if x2 implies x1 equal to x2, then the function is one-to-one. This is a converse statement of this. This is a converse statement of this, the previous statement. Or you can write conversely. If you can show in a problem that if x1 equal to if x2 implies x1 equal to x2, then the function is one-to-one. Mathematically, that will be proved. You can write down point 1, point 2 also. Note down point 1 because this is the starting of 12. Okay, Ishan, am I clear? So these two parts, you can show it mathematically. It's very difficult to show this one. We will generally stick to this one. In any kind of problem, if you want to check whether it is one-to-one or not, you can apply this one. This is a very beautiful. I will show you. Number 3. I will take some help from the calculus. You know the first order derivative. You know the differentiation. If you are differentiating something. So I will take the advantage of the differentiation. So if dash x greater than 0 for all x, okay, then the function is one-to-one. Or less than 0 for all x. For all x. For all x, not for some x after that it is negative. No, for all x it should be greater than 0. That means the function is increasing. If what is the significance of first order derivative? Tangent. It denotes the slope of the tangent, right? If dash x is dy dx at that particular point, that means if you have this curve, you can draw this tangent. This tangent, this is the slope at this point. This is the slope at this point. So that is the actually m is dy dx at that specific point. That is the significance of derivative, right? So if this derivative is continuously increasing, positive always, that means the function is monotonically increasing, strictly increasing. This is the notation for strictly increasing function. This is the notation for strictly decreasing function. You can write down in the bracket also. We will discuss again in the application of derivative. So this is strictly increasing. This criteria is for strictly decreasing. If you can test the function is strictly increasing or strictly decreasing, then you can clearly say that the function is one-to-one or injective. You can take a note of that. This notation, if dash x greater than 0 is strictly increasing, if dash x less than 0 is strictly decreasing.
second order derivative
Not now. Second order derivative is not here.
usage.
Second order derivative, rate of change of the tangents, rate of change of the slope. Third order derivative, rate of change of the second order derivative. Fourth order derivative, rate of change of the third order derivative. That means you are continuously differentiating. That means in kind of smooth functions you can do that. That is, I will discuss later. Clear? Is it clear? This is the third criterion. Fourth one, geometrically. How will you prove it geometrically? The function is one-to-one without any calculation, without doing anything. If you know the graph, you can check it very clearly. Can I rub the previous one?
Yes.
Geometry. So, suppose I have drawn a curve. This is a linear curve, right? Y is a function of x. It's kind of ax plus b type, straight line. So, if you can draw a horizontal line and that will cut the curve at exactly one point, then the function is one-to-one. Nothing to calculate, nothing to test. No need to test the derivative. If you know the graph, just draw the graph, draw horizontal line. If it cuts the curve at exactly one point, then the curve is one-to-one. Then the function is one-to-one, straight. So, horizontal line, if the horizontal lines cut the curve at exactly one point, then the graph is one-to-one or the function is one-to-one. Am I clear?
Yes.
Any questions?
Just similar to y equal to x square and x square.
Yeah. Okay. Now I can draw a few diagrams on that. Suppose, is this a one-to-one?
Yes.
No.
No.
If you draw horizontal lines, it will cut exactly 2 points.
Oh.
Right? Acha. What about this one?
So if you cut from
No,
Okay,
sir.
is
The
this a
tip.
Is this
No,
a
sir.
function?
No, sir. For the tips is blunt.
It is not a function actually. You see,
Yes, sir.
on one you have 3 images. This is not a function. So there is no question of one-to-one or what. Clear? You can take this type of concept in your mind also. Because graphical knowledge is a very important knowledge. It will give you a vast idea. You can check the limit, you can check the continuity, you can test the differentiability, you can test everything about the function in graphics. If you know the graphs, so that is a very important one. So this is about one-to-one, right? Now I will talk about on-to. So if a function is not one-to-one, that will be many one. If it is not one-to-one, then that will be many one. So your first type will be one-to-one. Number 2, many one. Number 3, on-to. Number 4, into. So this is called injective. This is subjective. So I have discussed these two. If a function is not one-to-one, it is many one. That's clear. Now I will go to onto or subjective. Or sometimes called subjection, injection, surjection, and if both, then it is called bijective or bijection. That will be. Now let me draw again diagram. Okay. Now your range set or image set is denoted by FA. That means F is actually carrying the points and creating the images. So your FA means FA, FB, FC. That means 1, 2, 3. Am I clear? Okay, no problem. I'm just writing 1, 3 and tell me 2. Yes. Clear? So this is the range set or image set, right? So I'm writing right, and it is a subset of B because 4 is not there in the set, so it is a subset of B, right? So image set is a subset of the codomain. Image set B is the codomain, right? So your range set or image set is a subset of the codomain, right? In this case, in the first diagram. What about the second diagram?
It is not a subset.
It is equal to.
So we can directly write this instead of.
Yes, you can see.
Yes.
1, 2, 3 are the only points and it is equal to. So if A equal to B.
But sir, if it was like both B and C are at 2, then
Both
B and C were pointing towards 2.
both B and C pointing to it. Then it will be not be, it is a subset of the codomain.
Oh,
3 has no pre-image, but everybody has a pre-image.
yes.
So range equal to codomain. So if this is the criteria for onto. This is the only criteria for onto.
But the previous one was.
Previous one is into. If range is a subset of the codomain, then it is a into. If equal, onto. This is a very clear cut. This is the only criteria. That means if any kind of functions, if range is a subset of the codomain, it is onto. Range equal to codomain, it is onto. Otherwise, it is into.
Less than.
It is into. Clear? So this is the, you can note down, take a note. I will start some problems on that.
So onto is surjective and
Into is not nothing. Actually, two names. 1 to 1 is sometimes called injective. Onto is surjective. If a function is both 1, 1 and onto, that is called bijective or bijection. If a function is both, you can note down. You may note down. If a function is both 1 to 1 and onto. If a function is both 1 to 1 and onto, then that is called bijective. Then that is called bijective. That is called bijective. Clear? Am I clear? Any questions on these types of functions? And this is the most important part of class 12 in calculus. Because if you don't have any idea about the transformation of functions, it's really difficult in the later stage to communicate. Transformation of functions is a more basic. Now I will start with some examples. So let us start with, I'm writing one function f from z to z. This is, you know, this is the writing of the functions a to b. I'm writing like this. So I'm writing fx equal to twice x belongs to z. Your z is the set of integers, right? So your mapping is set of integers to integers. And what is the definition? 2x. So if you have x here, you will get 2x here. Right? So if you have 1, what is the image? 2, 3. So you are getting even integers actually. Okay. Now you have to test whether it is 1, 1, whether it is 1, 2, or both, or neither. So tell me first.
Sir, it's a bijective.
It's a bijective, you said. Okay. Let me start with 1 to 1. Is it 1 to 1? My question is that.
It's 1 to 1 because every.
Okay, you can easily draw the diagram. That's easiest way. It's passing through the origin. It's a straight line, y equal to 2x. And if you draw horizontal line, it will cut at exactly 1 point. So it is 1 to 1. Okay. I will show you all the categories. I will show you length mathematically. If you want to write it mathematically, let x1, x2 belongs to z be such that right, that is your converse one. If x1 equal to fx2 implies x1 equal to x2, then it is 1 to 1. Am I right?
Yes.
So it directly implies x1 equal to x2. Hence it is 1 to 1. So I have shown it mathematically that it is 1 to 1. And also geometrically it is 1 to 1. Now I will take calculus, help of calculus. What is your fx? 2x. What is your derivative? It is always positive. So it's strictly increasing. Yes. You see the straight line strictly increasing. So it's 1. So 3 parts. Is it clear? So whatever you can do in your exam, you can take the tricks, whatever you suit, that you can apply and check whether it is 1 to 1 or not. No problem. Am I clear? Any questions on 1 to 1 part? So 1 to 1 is very easy. Now the question is 1 to 2. Acha, Ishan said it is bijective. That means Ishan said it is 1 to 1. Now what about Swapni? Hey, on to.
Sir, I mean, confused between that bijective and I meant to say that it is just 1 to 1.
It is 1 to 1. That means you said it is not on to, right?
No, sir, not on to.
I don't think it is.
Okay. You said it is on to. Okay. Why you are saying that it is not on
So
to?
because it is not a
That means
Odd integers are being left out.
yes. That means you are correct. That means your criteria for onto is range set. That means if set must be equal to the codomain. This is your codomain. And this is your domain. So fz must be z. But what is your fz? If you want to write some points, if you want to write some images on the fz, so what are the images? You see plus minus 2, plus minus 4, because I have negative integers also. Plus minus 6 and also 0. 0 is an integer, so 0. So it is 2z. Even integers, set of even integers only. 0 belongs to the even integer set, not belongs to the odd integer set. Because what is the odd integer? Odd integer will be like this.
Yeah.
You see, if you substitute 0, it will be 1. No. 0 belongs to the odd even integers. So it is even integer and it is a subset of z, not equal. So that is why it is into. You write the explanation.
So then for the 1 to 1 do we have both of them like geometrically and or just one?
Just I have shown all. In MCQ, whatever you feel, whatever is the easiest way, you do it. In MCQ. And if you have a broad type of questions, you have to show something, then you can go for mathematical. fx1 equal to fx2, that is the easiest way. You just equate the functions. If you get the x1 equal to x2, it will be done. Correct? Is it clear? The onto part, this is the most important part. These observations. You see, you have the picture. Pictorial. You do it mathematically later on. First, you construct your pictorial things in your mind. Just like you have seen a movie of Shah Rukh Khan, then you have a picture in your mind, so you can recall everything. Just like that. So you just visualize the abstract mathematics. Okay, shall I move to the next one? Okay, next one I will write f from, okay, okay, clear. Now, real number to real number. Mod x. Tell me. Yes, check.
So it's a many to one.
It's a many to one.
And into.
And into. That means neither injective nor subjective.
No, sir.
Yes. What is your mod x? This is y equal to x if x is positive. This is y equal to minus x if x is negative, right? So this is the structure. This is a modulus of x, and you see geometrically, if you draw a horizontal line, it will cut at exactly 2 points. For 1, you will get 2. Because you see, modulus of minus 1 is 1, and modulus of 1 is also 1. Modulus of minus 2 is 2, 2 is also 2. So minus 2 and 2 have the same image 2. Right? So it is not 1 to 1. But it is many one. Clear? Am I clear? This is geometrically. Mathematically, fx1 equal to fx2 implies mod x1 equal to mod x2 implies x1 equal to plus minus x2. If you remove the mod, then it will be plus minus. So you see, for x1, you have two values, plus x2, minus x2. So this is not one, many two. Am I clear? Geometrically, mathematically. Any questions? This one. This is the criteria, second criteria, converse one. Let x1, x2 belongs to R be such that. This is your assumption. You are considering fx1 equal to fx2. From here, you have x1 equal to x2. So if you remove the mod, plus minus.
Okay, plus minus.
So you have two values. You see here also. This is suppose minus 1. This is suppose 1. And this is your y equal to 1 line. So for y equal to 1, you have two pre-images. You see, minus 1 and 1. For y equal to 2, you have two pre-images, minus 2 and 2. Am I clear? Now am I clear? Have you understood? Any questions? 1 to 1. So this is not 1 to 1, but this is many to 1. Now what about surjectivity?
So it is into.
It is into. Yeah. Because you have real numbers. Real number to real number. You see,
The
This
negative
whole
side
thing
is-
is the real number. This is your
the
codomain
negative
part.
side is being left out.
But you see only positive part you have taken. So you have negative real numbers also. Suppose you have a negative real number -3. But there is no x such that mod x equal to -3. So -3 has no image. -3 has no image. -2 has no image. -1 has no image. Pre-image. So it is not onto, it is into. Because image set is a subset of the real number. Image set is a subset of the real number. Once again, I am explaining. Image set is a subset of the real number because you have negative numbers, real numbers also. -2, -3, -1. But there is no x such that mod x equal to -3 or -1 or -2. No solution of this equation. Modulus cannot be negative. Modulus is always positive. Am I clear?
Yes.
Understood? Any questions you can tell? Okay, Ishan? Understood?
Yes, sir.
Shapnil beta, understood? Now I will move to level some difficult level. If from R to R, what about this one?
So it is a one-to-one function.
Okay, one-to-one function.
And with the, you wanted like graphical kind of.
Whatever.
Become hard. a little
No,
bit.
graphical, it is a straight line.
Yes.
If it is a straight line, it is one-to-one without drawing anything. You can check that one if it's 1 equal to fx2. Testing.
Calculus is increasing than 1 to 1 and you increase.
1-to-1, but throughout, for all. There are some functions like if you draw this kind of function, suppose this, you see here it is not increasing, it is constant. Parallel is derivative, it's parallel. No, it is not strictly increasing, it is not 1-to-1. It should be strictly sharp. Now for this function, now if you want to start, let mathematically. Same writing. It is x1 equal to x1.
And sir, I think it will be a onto function because for every point of y we get a point in x.
Yes, yes, yes.
It's a straight line throughout.
Geometrical calculus.
So can you like for this can we draw straight line anywhere?
This is you can y equal to 3x plus 1. So so what is the intercept? -1/3. This is 1. You can write the intercept form of the line. Straight line. If you see straight line, 1-to-1. Nothing to check. No need to be worried.
So by looking at the question, how do you understand that it's straight
Are you linear?
or? Oh,
Y equal to 3x plus 1. Y equal to ax plus b. That's a straight line. Standard form of a line. You have to know this is standard form. Standard form of a line, standard form of a circle, standard form of a parabola, standard form of an ellipse. Just go through it. Just go through it. Before we come to the next class, these things should be in your mind. Just go and take the revision on them. Just the standard forms, formula, whatever required here, we are doing. So you need to become. So this is in from calculus also. We have shown that it is 1-to-1, right? Now I will show onto. Yes, Ishan is correct. And Shopnit is also, you said it is onto. Right, Shopnit? So we have to show this is onto.
Sir, graphically we can show that as it is a straight line all throughout.
Yes.
For every point of y we get a point.
Yes. It's extend from minus infinity to infinity. So it is onto. That is without calculation anything. But you want to show mathematically. Suppose. So if you want to show mathematically, let us take an arbitrary element y in the codomain. So what I have taken y in the codomain. This is your codomain, and this is a horizontal part is a domain. So I have taken a point y in the codomain, and I have to check whether I have a preimage or not. I have to check is y having a preimage, that I have to take. That I have to check that whether it is here a point exists or not. That I have to check. So y equal to, so let me calculate here. Y equal to 3x1. What is your x? So that means if x equal to y, if y is a codomain point in the codomain, we can write if x equal to y. So if x is 3x plus 1 equal to y, so what is your x? Is this belongs to real number? Is this a real number? If y is a real number, is this a real number? Obviously. So that means this is the point y minus 1 by 3. Am I clear? If y is a real number, y minus 1 by 3 is a real number. That means if y is a preimage, if y is a point in a codomain, then we have a preimage in the domain y minus y by 3.
So essentially, why is the
No, you have to test like this mathematically. Mathematically, you have to write like this. Clear? Now y is arbitrary. So that is why for every element in codomain has a preimage. Every element in codomain has a preimage because y is arbitrary. But if instead of real number, if we take z to z, this is a onto.
No, sir.
Because this doesn't exist. This is a
Yes, sir.
fraction. This doesn't exist in the codomain. Am I clear?
Yes.
Have you understood? Please take a note. This belongs to this calculation part. After that, write. After this calculation, you write the calculation first. Okay. Now write, since y is arbitrary. Since y is arbitrary, each element in the codomain set R, each element in the codomain set R has a preimage under F. has a pre-image under F. Has a pre-image under F. Therefore, F is onto.
Your mic is muted. Sir, your mic is muted.
Can you hear me?
Yes, sir. Now your camera is switched
Yes.
off. Yes, sir.
Now I will give you a chart of series of problems. You have to draw the table at your home. This is your assignment part. Examine if fx is injective one-to-one or surjective onto. Before that, I will ask few questions on that. Let me give you more questions on that because this is a vast idea. Can you give me an example? Injective but not surjective. That means one-to-one but not onto. This is number one. Number two, not injective. Yeah. But subjective. Number three, neither. Number four, bijective.
Sir, will you please read it out once?
Injective but not surjective. First one,
No, sir, the heading. What is the heading?
examine. That is later on. I haven't finished that part. Just first you give me these examples. Injective but not surjective. That means it is one-to-one but not onto the previous one. Z to Z. Yes. Correct. F from Z to Z, fx is 2x. Right, Ishan?
Yes, sir.
This is injective but not surjective. Next, number 2, not injective but subjective. Mod X. That is neither nor.
So sir, f is equal to x.
Huh?
F is equal to x.
Then it is both. Acha, I am giving you one example. Not injective. F from real number to set of integers. Fx equal to box 6. Greatest integer function. What is your greatest integer function? It will take only integral values. What is the graph? 0 to 1. What is box 6? 0. Right? 1 to 2.
1.
2 to 3. It's just like a state function. So it is not on to, because if you draw, there are so many points, and it is. But you see, it will take only integral values. What are the values it can take? What is the image set? What is the image set? 0, plus minus 1, plus minus 2, plus minus 3, etc. So that is nothing but your code only. Because greatest integer function usually takes the integral values. It cannot take other values.
Z to Z, fx equal
Z to Z, that means, yeah, then it will be injected. Yeah?
Okay.
Am I clear? Ishan, clear?
Yes, sir.
Okay. So 1, 2. What about 3?
Sir, that mod X.
Mod X. Neither injective nor surjective. 4, bijective.
Sir, just x. Fx equal
Any kind of linear function. R to R. Real number to real number, any kind of linear function. Any kind of 3x plus 1, 5x plus 2. Say any kind of linear straight line. Okay. Can I rub this part?
So the bijective thing is
Bijective means it is injective and surjective.
not something like this.
Bijective. A from R to R, fx equal to suppose 3x plus 1. X belongs to R. For bijective, it should be
Sir, if it was Z to Z, it wouldn't have been that.
no. Yes. It should be injective.
But sir, if it was Z to Z, but x belongs to Z, then
Z to Z, this one.
yes. But x also belongs to Z.
Okay, it should be belongs to Z. No problem. Then it is not surjective.
Oh,
It is not surjective because you have a fraction.
yes.
If you take the pre-image, if you take the y in the codomain, you will have y minus 1 by 3. That doesn't belongs to Z. That means y has no pre-image. Not all the values are pre-image. Some values are pre-image, some values are not. So it is not only. Am I clear, Swapnil? Okay.
Sir, 4 তো হচ্ছে।
4.
y equal to
Y equal to 4. Some values. You have some values where pre-image exists.
হ্যাঁ স্যার, তো কিছুগুলো
But
হলে তো হবে। হ্যাঁ।
if there is at least one value where it doesn't exist, it cannot be on. It cannot be. একটা পয়েন্ট যদি থাকে তাহলে হবে না। Yes.
Sir, basically most of them bijectives are
Bijectives from R to R. Yes. Now I will give you one difficult problem. If from please take a note of that problem. What is the meaning of this?
Every real number except one.
All real numbers except one. One is not there. You just throw out that one and you are considering the whole real. This is also the same. That means your mapping is without one. And you have this function. Now you have to check whether it is one to one or not. Mathematical test. You will go for mathematical test.
it is not.
You go for mathematical test. Fx1 got fx2. Go ahead. Go ahead.
So it is one.
It is 1 to 1. You are getting x1 equal to x2, right? Yeah. So you are writing what you are writing? Let x1, x2 belongs to, this is your domain. You see, you are considering points in the domain for checking 1 to 1. You are considering points in the codomain for checking on to 2. Okay?
And if it is not on the
So what you are getting? Okay. So you are getting x1 equal to x2, right? It is 1 to 1. Finish. That part is easy. What about the other part? That means you have to go for y belongs to your codomain. You have taken considering a point y belongs to y. Now you have to check whether the pre-image exists or not. Check the pre-image. What will be the pre-image? What will be the pre-image of y?
Yes, sir, it will be onto function because x is only not defined when y is 1 and y1 is already excluded.
Very good. This is y is a function of x.
Yes.
So you can write x equal to component divided into what will be the result? Y.
Sir, minus y minus 1 divided by y
plus
minus
1 by y minus 1, right?
Yes, sir.
So it belongs to r minus 1 because 1 is not there. Correct? If it is a real number, it doesn't exist because of this y minus 1. But 1 is not there in the set. So it exists. The pre-image exists. The pre-image exists. That is why it is on. And it is why it is arbitrary. You just draw the sketch also alternate, side by side.
So if it was instead of one any other number,
Then it doesn't exist.
just because it is
Suppose instead of this it will be 2, then it doesn't exist. Because you have y minus 1 in the denominator. It shouldn't be exist for other numbers. Only for y not in that set.
So if it would have been f z minus 1, then it will have been
Into. Am I clear? So this mapping is 1 to 1 now. One more interesting problem involving complex number. I give you. Am I clear? Let C be the set of complex numbers. Modulus.
So it is,
C be the set of complex numbers. Look at the mapping. Mapping is from complex number to real number.
that is neither it's neither subjective nor on
Neither injective nor on subjective. Check. Very good. Your answer is correct. Just arrange logically. Ishan, what is your answer?
সে একটা ভি শেপড গ্রাফ আসবে তো তোমার নিদার ইনজেক্টিভ নট বাইজেক্টিভ কি ছিল নিদার 1 to 1 নট অন টু
But this is complex number.
হ্যাঁ স্যার কমপ্লেক্স নাম্বার সেটার জন্য আমি কিছুক্ষণ দাঁড়িয়েছিলাম মানে
Mod z is the distance between the point, distance of the point from the center,
হ্যাঁ স্যার
origin. You consider two complex number, any two complex number.
Since here z is the radius of the circle of the complex.
So if you take z1 2 plus 3i and z2 2 minus 3i. So what is your mod z1? Root 13, right? But you see that the points are different.
Yes.
It is the conjugate points. Right, Ishan?
ইয়েস স্যার
So how do you do
Root over x square plus y square.
yes
So 4 and 9.
oh yes
Real part square plus imaginary part square. So I'm relating.
সেটাই বলছিলাম যে একটা ভি শেপ গ্রাফ হবে
Okay,
আর
okay,
যেহেতু
okay.
তোমার কমপ্লেক্স নাম্বারটা তুমি এক্স অ্যাক্সিসে দিয়েছো তার জন্য এটা ফাংশন হবে আর যদি কমপ্লেক্স নাম্বারটা ওয়াই অ্যাক্সিসে থাকতো তাহলে এটা ফাংশনই হতো না
Very good, very good.
মানে যেহেতু সি টু আর ম্যাপ করেছো আর টু সি ম্যাপ করলে সেটা ফাংশন হতো না
And what about the onto? How will you explain the onto part?
তোমার নেগেটিভ পার্টটা নেই
Yes. Because real number it has some negative part also, but it is only modulus means only the positive. Clear?
আর স্যার
Hmm.
আর টু সি ম্যাপ করলে এটা ফাংশন হতো না না
Now,
so R is equal
C is a very big portion. C is bigger than, actually all real numbers are complex numbers. তাহলে x2 complex number এর ম্যাপ হবে না, সব 0 হয়ে যাচ্ছে। Okay, now I will give you some chart. I was talking about some chart, so you can test. This is for your assignment. I'm writing the numbers. Number 1. So these are A from R to R. Just like you can arrange like this: 5x plus 2, x belongs to R. You can write here injective, surjective. So you can write this. I'm just showing the first one. I will give you the set of problems. You just complete the chart by yourself. I'm just showing the first one. Number 2. And if you find any kind of functions like this in the problems, in the books, or in JE papers, you just complete the chart. Suppose I'm giving you today 17. You complete the chart by 30 more questions. So you have a chart, beautiful chart with you, and all the kinds of functions. Just I have explained the functions. This is set of rational numbers. This is set of integers. This is rational. Sin x. Isan, can you see the board?
Yes, sir.
Can I have the upper part? If it is not injective, you just put a cross over there in your chart, like this. And no need to write into and onto, many one. Because if it is not injective, it is clearly many one. If it is not subjective, it is clearly into. So no need to write those two columns. These two columns are important. Natural number. Huh? If you don't know any notation, please tell me. I'll explain. Yes, yes, I'm explaining it. All real values in -1 to 1. All real values in -1 to 1. Can I write the lower part now? This is already solved, but still I want to put it in the chart.
So, like, if the exam should be given like this, like then injective or subjective, or you need to show them.
In question, you have to write the explanation. In that case, you have to show it like that. If you have an MCQ problem, you can easily go ahead with any kind of methods. Whatever you feel good for you. You can test calculus, you can test it for geometrically. Without calculating also, you can test the problem. This is greatest integer function, okay? Here 17. I have still 17. You can collect more, and if you find more, you just share with me also. Just the problems. I will increase the sheet.
So in GE means regarding the GIF, there are some formulas.
Okay, I will give. No problem. You want those?
It's series
Okay.
for
Okay, no problem. Okay, one more thing. Let me move on. Can I wrap this whole thing? Now, next part is if a function is bijective. Then the inverse exists. If the function is bijective, then the inverse of the function exists, otherwise not. That means the function should be 1 to 1 and 1 to 2. Otherwise, the inverse doesn't exist. So just for example, already we have solved one problem on that. If from R to R, fx equal to 3x plus 1, already solved that this is your 1 to 1 and 1 to 2. So what is the inverse function? Y equal to 3x plus 1. So x equal to y minus 1 by 3. So this is the inverse function, actually the pre-image. That will give you the inverse function. So we can write f inverse from R to R as f inverse x equal to, or you can write, you can write this x minus 1 by 3. This is the inverse function. So only criteria for inverse existence of inverse is bijectivity. So my question is, now I will go to some few problems on trigonometry to inverse, check the inverse, whether the inverse. Again, I will repeat the same thing on inverse chapter of trigonometry. This is the functional inverse, okay? So in case of inverse, this is the domain and this is the codomain. So if it is the inverse, this will be your domain, this will be your codomain. Correct? Okay? Now you tell me your sin x. Is it 1 to 1 or 1 to 2?
Yes, sir.
Where? Is this 1 to 1 and 1 to 2?
Yes, sir. It is 1 to 1 and 1 to 2.
This sin x.
Yes, sir.
So but when you got it,
A from R to R. No, it is not 1 to 1.
so because when you got it, it's gonna have many points.
Many points.
First and second point.
Ishan,
Oh, yes, sir.
We'll get
so I have to cut the curve to make it sectionally, it is 1 to 1 and 1 to 2. So I will arrange like that.
so because sin is positive in first.
Now check.
Yes, so that.
So what I've done, I'm just taking a slice of minus pi by 2 to pi by 2. Check, it is 1 to 1 and 1 to 2.
Yes.
So inverse of this portion exists from it. Because this is now bijective.
So even if we take the first portion, it won't be,
No, you can take the next part also.
but it will have.
This is the principal part. So near the origin is the principal part. You can take other portions also. So it is sectionally 1 1 on 2, not as a whole. It is sectional. So I'm taking this now. How to draw the inverse?
So by finding out the data.
You just write your y equal to x and take the reflection on y equal to x.
So can't we find it by dividing?
Huh. So I will take the by dy dx inverse.
Yes.
No.
Tangent.
Oh, for by doing tangent. No, I'm just doing this graphically. This is the inverse graph. See this portion.
Yes.
Because this is the reflection on y equal to x. Okay, Ishan?
Yes.
I will explain this again in inverse chapter. Well, Swapnil, any question?
Sir, because sin is positive only in first and second coordinate, like that we are taking only sectional parts.
No, that is not the only reason. I am taking
Means
it
for explaining many to one.
many to 1. That is one. Because if the function is not bijective, its inverse doesn't exist. For the existence of inverse, bijectivity is the main criteria. It has to be bijective. That means it has to be 1 1 and 1 2.
This wasn't such
This, the previous one was not, but this one is subjective and injective. That is why we have sine inverse x
Sit by
by j. This is the inverse part. Now I will explain composition of functions.
Since all trigonometric functions are like on the sectional part is inverse.
Yes, if you will draw the cosec also.
So that means only that part is by just.
0 to pi. If you have 0 to pi. Okay. So how will you draw the inverse? Take y equal to x. This is the inverse. Okay.
Inverse is only